In this video, we're going to discuss Stuxnet and Flame and analyze how they were used to compromise Iran nuclear power plants. We'll start off with a discussion of what Flame is, how it's installed, and how it spreads. We'll move on into Stuxnet, what it is, how it's installed, and how it spreads. We'll talk a little bit about the creators of Stuxnet and their motivation behind creating Stuxnet. We'll discuss Stuxnet's execution, specifically how it infects a system and how it negatively impacts a system. And even more specifically, we'll go into detail about how it was used to attack Iranian nuclear power plants, including Flame's role in the attacks. Since Stuxnet was the first of its kind that was really used internationally against another country, we'll talk about the precedents that it set, as well as other political considerations. And finally, we'll discuss mitigation and remediation efforts and considerations for those infected by Stuxnet and Flame. First, we're going to discuss Flame, the undercover spy. Now, instead of adversely affecting systems and trying to take systems down, Flame essentially just spies on the systems to try to get confidential info. Specifically, it's trying to get confidential info within PDFs that are specific to an organization, that have confidential information such as competitive advantages. It also records Skype conversations and keystrokes and takes screenshots. While it's doing all of this monitoring, it inconspicuously transfers data in tiny segments in order to not be detected. Rather than sending all of the data at one time, this would be a large chunk of data and easily detected by the seasoned network administrator. So Flame is very smart in its design that it breaks down data first so the packets are very, very tiny and hard to detect that something wrong is going on. One very unique thing about Flame is that it was actually discovered after Stuxnet while the Stuxnet code was being analyzed by Kaspersky Lab. So they found that it's actually a precursor to Stuxnet even though it was found after Stuxnet. How was Flame installed and how did it spread? Hackers could directly infect a system with the worm running on a USB drive by plugging the drive into a computer. The most egregious way that it hit computers was off of a Microsoft Windows update to Windows 7. It happened because of a flawed hash function that was taken advantage of. It was a compromised certificate that hackers were able to basically push the worm through Microsoft Windows Update. And then once the worm infects the first device, it can start spreading over Bluetooth up to a 2-kilometer distance away. And it can even be used to install other malware over Bluetooth. Now we're going to discuss Stuxnet, which could be classified as the undercover executioner. It's near impossible to detect due to its tactical execution. Rather than attempting to infect and attack the entire system, it specifically attacks German manufacturer Siemens software, specifically Simatic WinCC in Step 7. So if a machine doesn't have this software, it basically will not be able to tell that it's infected. There's not going to be any signs of it being infected. It's just basically going to be used as a proxy to harbor the worm to other machines in the network. The physical PLC devices connected to systems can even become infected by Stuxnet, which puts them at risk for being adversely affected. And finally, the worm can download a newer version of itself on the internet once it exists on a system. This helps it to execute new zero-day exploits on the newer version. How exactly was Stuxnet able to compromise systems? Initially, a hacker would plug a USB drive into a device. As part of the Stuxnet code, there's a certificate that's accepted as legitimate from anti-malware suites. After initial infection, the worm can traverse the internal network to infect other machines on the network. So segmentation from the internet can be futile if the machine is connected to other devices on the LAN. And finally, if another USB drive is plugged into a machine that's infected, that USB drive will pick up the worm, and then any other machines where that specific USB is plugged into will get infected by the worm. Once Stuxnet is installed onto a system, what does it do next? Well, first it needs to detect if the machine has the appropriate Siemens software installed on it that it wants to compromise. If it doesn't have the Siemens software installed on it, then it's just going to use the compromised machine to harbor the worm onto other systems within the network. If it does have the Siemens software installed on it, then the next step consists of spying and gathering of information to optimize the attack strategy. There's different specific controllers, and Stuxnet's going to try to determine the best way to take down the specific controller that's part of the system that it's infected. And the other thing is, rather than attacking right away, Stuxnet is very tactical in its execution. It's going to gather information first to optimize its attack, whereas a lot of worms and viruses and other malware will attack right away. Stuxnet is very strategic in its execution. Finally, Stuxnet will execute its attack stage, where it's going to send misleading readings to the control panel. This is going to misguide operators, where they're going to think that nothing is wrong with the system. While this is happening, it's going to overwork centrifuges and the system until it spins itself to death. Who is the creator of Stuxnet? There's speculation as well as a strong suggestion that it was a joint venture between the United States and Israel as a state-led operation. The design of Stuxnet really calls for a massive project that's not too capable of private businesses or especially individuals being able to pull off. Reasons for this are that you would need an isolated lab for testing, because the malware as exhibited can just get out of control and easily take over. It would have been hard for an individual or a small group of people to really analyze how to make such a hard and direct impact. We're going to discuss motive more, but behind the attacks, what were the actual motives? And individuals and small businesses, even larger businesses, really wouldn't have had the motive that the United States and Israel had. And finally, there's the element of risk, where a private business or an individual really wouldn't want to risk taking systems down with such a potent worm. As aforementioned in the last slide, there was motive behind creating Stuxnet, because why would you want to make a worm that's so potent and so powerful against a specific system? The agreed upon consensus is that the United States and Israel wanted to target Iran to harm their nuclear potency. They wanted to minimize their nuclear arms as well as keep competitive advantage in regard to war. During the execution of Stuxnet, who was targeted the most? The Natanz plant was targeted the most in Natanz, Iran. About 1/5 of their centrifuges were broken due to Stuxnet. This really puzzled Iranian scientists, because physically, when they investigated the centrifuges, they appeared to not have any hardware faults at all, and they were just failing for no good reason. This attack went undetected for several months. Then, security experts suggest that Israel strengthened the malware, which made it easier to detect. Although it was more potent after the strengthening, it was much easier to detect. So where does Flame come into play with the execution of Stuxnet? While Flame was most likely used to probe the Iranian plants, it gathered specific details such as the centrifuge models, what Siemens software to attack, and other elements such as those things. It determined the best methods of attack. And finally, it helped guide the decision for the US and Israel to attack specific Siemens software, because Flame sought out that they run high-speed centrifuges that help to enrich nuclear fuel in Iran. Before we discuss the mitigation and remediation efforts, it's noteworthy to discuss the precedents and political considerations of Stuxnet. Stuxnet was the first worm that could actually destroy something physically. Before Stuxnet, data or systems could be corrupted by worms, but not completely taken down. Stuxnet was the first of its kind in this regard. Stuxnet started a trend of malware being used in international attacks. Russia used a malware called Black Energy against Ukraine. This actually put hundreds of thousands of Ukrainians without power in the middle of winter. There was a steel mill in Germany destroyed by hackers overriding controls panels. It's unknown which country pulled this off, but there's an expected foreign interference. Along with these precedents comes new political considerations. Specifically, there are countries with the means to produce malware such as Stuxnet, and they have no real motivation to regulate the use of such malware internationally. And the reason for this is that there's a competitive advantage that these countries have over other nations. Just like traditional warfare, countries can have competitive advantages over each other in cyber warfare. Finally, another scary concept in this regard is with terroristic ploys. Malware could be used to disrupt air traffic controllers, railways, and just cause disaster and accidents against people. So now that we know that Stuxnet is a very potent worm, what can organizations do to protect themselves against Stuxnet and prevent it from happening to their organization? Well, first, there are 2 Microsoft Windows updates that all systems should have installed, specifically per bulletin MS10046 and MS08067. The first of which fixes a security hole that Stuxnet uses to infect the system via USB. The second of which fixes a security hole that is known to be abused, but is unknown specifically how it is abused. Regardless, experts recommend this to be installed to protect against Stuxnet and other similar worms. From the perspective of security policy, it's very suggested to lock down the use of USB drives. This really helps minimize attack surface and the chance of a worm being installed onto a system. What should an organization do if their systems are infected with Stuxnet? They should always first consult with Siemens support and the organization AIT613. There's a general 3-step process that these organizations recommend. The first is to install the Microsoft patches in the aforementioned slide. The second is to run a proprietary tool from Siemens called the sysclean tool. And finally, they should install a Simatic application security update for all systems that are running the Simatic software. Organizations need to be careful and consider some fallout even after the Stuxnet worm is remediated. Specifically, Stuxnet can affect Windows registry keys. Cleaning and patching a system will not undo these registry key changes. It is possible to go through the registry manually, but it really is a better idea just to reinstall Windows completely on the affected system. Another important concept is that Stuxnet has the chance of infecting the physical PLC devices that are connected to the system. So analysis of the hardware by Siemens and ICS-CERT experts is highly advised after a Stuxnet infection. To summarize, Stuxnet and Flame were both very intricate and unprecedented, including their usage. Both spread like wildfire and were near impossible to detect due to their design. Both were used to negatively impact nuclear production in Iran. There are mitigation and remediation efforts which administrators should carefully apply to safeguard their systems from Stuxnet and Flame. Both worms demonstrate the importance of safeguarding systems and implementing policies such as USB restrictions to protect systems.